This video is recorded to help my students to understand how to use the chi-square distribution to estimate the standard deviation of the population. Key point: the sample variance S square is the best point estimate of the population variance sigma square. Hence, the sample standard deviation S is a commonly used point estimate of sigma, even though it is a biased estimate. So we will use the chi-square distribution. Notice the chi-square distribution is not symmetric, unlike the normal distribution or student t distribution. As the number of degrees of freedom increases, the chi-square distribution becomes more symmetric. The value of chi-square can be 0 or positive, but they cannot be negative. This chi-square distribution is different for each number of degree of freedom, which the degree of freedom is n minus 1. N is the sample size. As the number of degree of freedom increases, the chi-square distribution approaches a normal distribution. So we normally need to calculate this chi-square value such that on his right tail equal given probability or significance level, or on his left tail equals some probability or significance level. So in this case, we will use this formula to calculate this right tail chi-square value. We say chi-square dot inverse dot right tail give the probability, which is the area of this right tail, then give the degree of freedom. For example, this degree of freedom is 9. Now, if you want to calculate the left chi-square value, you will use chi-square dot inverse with the area of this left tail with the degree of freedom. Let's say example. Determine the two chi-squared critical value for the following confidence level and sample size 90% and the sample size equals 30. So your alpha will equal 1 minus 0.9, 90%, right? Then your n is 31. So the degree of freedom will equal m minus 1, which is h7 minus 1. Okay, so degree of freedom is 30. So chi-square left will equal chi-square dot inverse. Okay, then the probability on the left side, probability will be equal half of the alpha, so will be equal h6 divided by 2, and the degree of freedom will be h8. Okay, so that's your left side. Then the right side one will equal chi-square inverse dot right tail. Then you will say probability again is alpha over 2, h6 divided by 2. Then the degree of freedom will simply just h8. Okay, so you have this. Now, next example. Suppose we are interested in estimating the population standard deviation sigma for the life of AA battery in toys. We will assume that the battery lives are close to being normally distributed. Below are the life of in the hours of battery in toys. Now those are the data. Construct a 95% confidence interval to estimate the sigma. So you first copy the data to the Excel in one row. Okay, you need to understand the formula we use is here. So this sigma square is the population variance. Then n is sample size. S square is the sample variance. Chi-square R is the right tail chi-square value. Chi-square L is the left tail chi-square value. Okay, so we first say alpha will equal 1 minus 0.95. So your alpha is 0.05. So each tail will be half of the alpha, 0.025. Then your variance will equal, you use the formula variance for the sample. Then you drag it down the data range. Okay, then you hit enter key, then the 3.43. Then your n, you can use count if you wish to. Now this count, wait, I need to put inside of this parenthesis, then go down. Okay, this kind of 16. Degree of freedom is always equal J 7 minus 1. That is 15, which is your size minus 1. Now, chi-square left will equal chi-square dot inverse. Now, probability will equal alpha over 2, which is J5 divided by 2. Then degree of freedom with J8. That's your left. Now, chi-square right will equal chi-square dot inverse dot right tail. Then the probability again is J5 divided by 2. And the degree of freedom is J8. Okay, now the calculate the left limit for we will use this formula here. Notice you do not need to calculate standard deviation because you calculate standard deviation, you still need to calculate s squared, right? So why we don't just use x squared, which is variance, directly in this formula, but you remember s squared is the variance. So you will use the upper limit will be square root of n minus 1. N minus 1 is actual degree of freedom, which is J8. Then multiply s squared, which is variance, which will be in J6. Okay. Then you divide by chi-squared left, which is in J10. Okay. Now, then the upper limit, you will use square root. Then will be the lower limit, square root of n minus 1, which is J8. Then multiply the variance, which is J6. Then divide by chi-square right. So which will be chi-square right in J11. Okay. So that will be your lower limit. So we construct a 95 confidence interval for this population sigma is between 1.369 to 2.869. If you have any questions, please give me an email.